Hello everyone, let's continue to study the fourth chapter, Subgrade design. Now, I will introduce the second part, roadbed design and cross-section design. In this part, I will introduce the following contents: the definition of subgrade, roadbed design, fill cross-section design, and cut cross-section design. First, let's look at the definition of roadbed. Roadbed can be defined as the subgrade part that is 80 cm or 120 cm below the pavement structure. While the depth of the roadbed is different, traffic levels affect the depth. For light, moderate, and heavy loading traffic levels, the depth of the roadbed is 80 cm in this figure. For very heavy and extremely heavy traffic loading levels, the depth is 120 cm in this one. For the roadbed, which can be further divided into the upper and lower roadbed layers, the upper roadbed layer is 30 cm. The lower roadbed layer is 50 cm for light, medium, and heavy traffic, or 90 cm for the very heavy and extremely heavy traffic. For some highways with special axial loads, the working area should be calculated, and the roadbed thickness should be determined based on the working area instead of 80 cm or 120 cm. Let's learn about roadbed design. The design of roadbed mainly controls CBR and compactness. On this basis, the design standards of roadbed is put forward. Now look at the CBR. CBR is employed to characterize the roadbed soil mechanical property. Roadbed filling materials should be uniform. The minimum CBR should meet the requirements listed in the table. The table lists the minimum requirements according to the National Design Specification, which is dependent on the highway class, location, and traffic loading levels. For example, when the highway is first class, traffic level belongs to the highway traffic, then the depth of roadbed is 0.8 meter, and the CBR value of upper roadbed need to get to the minimum value 8%. And lower roadbed need to get to the minimum value 5%. Then, look at the compaction requirements. The subgrade should be constructed layer by layer and compacted accordingly. The maximum grain size of fill materials should be less than 100 mm. In order to drain rainwater falling on the top of roadbed, cross slope is set. The cross slope of the roadbed should be same as the pavement cross slope. The degree of compaction for subgrade roadbed should meet the requirements as listed in the table. The table lists the requirements is dependent on the highway class, location, and the traffic loading levels. For example, when the highway is first class, traffic level belongs to the highway traffic, then the depth of roadbed is 0.8 meter. The degree of compaction of upper roadbed need to be equal and bigger than 96%, and the lower roadbed also need to be equal and bigger than 96%. There are two kinds of criterion of the subgrade, such as resilient modulus and verification criterion. The major criterion of subgrade design is resilient modulus on the roadbed surface, and the verification criterion is the vertical compressive strain on the roadbed surface. The resilient modulus of the roadbed surface under equilibrium moisture conditions should meet the corresponding requirements in asphalt pavement or cement concrete pavement design specification. The vertical compressive strain on the roadbed structure for asphalt pavements should meet the asphalt pavement permanent deformation control requirements, whereas the vertical compressive strain on the roadbed surface requirements is not necessary for cement concrete pavement. Now, I will introduce the field cross-section design, which are introduced from the field subgrade geometry design and the field materials. One side, field subgrade geometry design. We have now the three key elements of a field subgrade geometry are width, height, and slopes. For the width, which is dependent on the class of highway, includes travel lines, central reserve, road shoulders, etc. For the height, we should consider the following factors. The height should meet the requirements of flood frequency and flood level. Embankment should be higher than the critical height of moderate moisture conditions. We should also consider the subgrade work area depth. In the seasonal frozen region, embankment height should be larger than the local frozen depths. For the field slope, the following three conditions should be considered when one designs. First of all, the slope ratio depends on the property of the slope soils and slope rocks, hydrological conditions, and slope height. Second, for the embankment with good geological conditions and less than 20 meter height, the slope ratio should not be steeper than those present in the table. Third, for field higher than 20 meter, step-shaped slopes should be constructed, and the stability should be verified with the simplified Bishop method. Last, for the submerged slope section of the socked embankment, the slope ratio should not be steeper than 1 to 1.75. The other side is field materials. It should be noted that the embankment in this section refers to the subgrade part that is below the roadbed. The embankment is divided into upper embankment and lower embankment in structure. The upper embankment refers to the range of 70 cm below to the bottom of the roadbed, and the lower embankment refers to the feeding part below the upper embankment, as shown in this figure. There are different requirements for subgrade field in different parts. Graded coarse soils like gravel and sand are preferred as the fill material for embankment, and the maximum grain size should be less than 150 mm. Fine-grained soil with a liquid limit higher than 50% and a plasticity index larger than 26 should not be directly used for embankment construction. The minimum requirements of CBR for embankment fill materials is listed in the table. From the table, we can know the CBR value requirements needed to be satisfied with the upper embankment and the lower embankment under different heavy class and traffic loading levels. The embankment should be constructed layer by layer and uniformly compacted. The degree of compaction should meet the requirements as presented in the table. At here, I will introduce the ordinary cut subgrade design, which means cut subgrade edge height is less than 20 meters for the soil slope or 30 meters for the rock slope. Cut slopes are dependent on hydrology, geology, slope height, drainage, protection measures, construction methods, etc. The ordinary cut slopes for soil can be determined through the recommended value as listed in the table. For example, when the soil is clay, the slope ratio can be chosen as 1:1. Well, the table is for the ordinary cut slopes for rocks. The slope ratio can be determined by the rock types, weathering degree, and the edge height. For example, when the rock is belonging to type 2 with lightly weathered, the edge height is 8 meters. The slope ratio can be chosen between 1:0.3 and 1:0.5. When reliable data or experience is available, the cut slope is not restricted by this table. Okay, let's summarize this section. We have introduced the following contents: the definition of roadbed design, fill cross-section design, cut cross-section design. Thank you for your attention. See you next time.